11001. You can put on the 2 for sure, say it's binary, base 2. Right? So this is what the computer see when you input 25 in the computer. Welcome back to Learning with the Passleys. Welcome back, people. Welcome back to the channel. If it's your first time watching this wonderful and informative YouTube channel, please feel free to like, share, subscribe so that you will be notified of our future uploads. Yeah, man, people, I have a very interesting topic for you today. Yeah, man, a very interesting topic coming at you. Today's topic is convert decimal to binary. So we talk about base 10. We talk about decimal, so base 10. And when we talk about binary, we are talking about binary. We are talking about base 2. Base 2 numbers. Yeah, man, so base 10 numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 digits, right? And for base 2, we have only 2 digits, which are 0 and 1. So ones and zeros. These are the numbers that the computer see, or these are the numbers that the computer read when you input information in the computer. So it doesn't matter what letter or number you input into the computer only sees the number as ones and zero. So this is basically a mathematical topic. It is also information technology topic. So you will also do this in mathematics, and you will also do this in information technology. So the computer only understands ones and zero. So when you put in a letter or letters in the computer see the letters or numbers as ones and zeros. Alright, so base 2 is binary numbers, right? And base 10 is decimal. So today, I am going to teach you how to convert a decimal number to a binary number. Yeah, man, today I'm going to teach you how to do that. Alright, so we know that decimal is base 10 numbers and binary is base 2 number. Right? So, what if you were given 25? So when you see 25 with the 10 here, this is telling us this is a base 10 number. It's a decimal number. Right? It's a decimal number, base 10. Right? And you want to convert this decimal number into binary. So we know that the binary is base 2. So since we are dealing with base 2, we're going to use the base 2 to do some calculation. So we're going to have 2 to the 0 power, 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power, 2 to the sixth power, 2 to the seventh power. What does this mean? 2 to the 0 power give us 1. 2 to the first power give us 2. 2 to the second power give us 4. 2 to the third power give us 8. 2 to the fourth power give us 16. 2 to the fifth power give us 32. 2 to the sixth power give us 64. And 2 to the seventh power give us 128. So we basically do the exponent of base 2, right? So when I say base 2, 2 to the first, right? So 2 to the second power means that we multiply 2 times 2 give us 4. Make any sense? 2 to the third power give us 2 times 2 times 2 times 2, which is the same thing as 8. So this is how we get these numbers down here, right? So now we have these numbers. I can erase these numbers up here because I don't want the confusion, right? So if we look at these numbers now, we basically double the number each time we write a number. So we have 1, so we double the 1, so we say 1. Then we have 2, so we double the 2 and we have 4. And we keep doubling the numbers so till we reach up to 128, right? So we can just draw some line here to create a little table. Don't want the confusion. So we want to write this 25 into binary. So I need to add up these numbers that will equal to 25. However, the numbers that I want to add, I have to put 1 there. And the number that I don't want to add, I have to put 0. Right? Make any sense to you? So, since we have 25, I am going to look for the number that is the highest number. I am going to look at the highest number that is smaller than 25. And that would be 16. So 16 is the highest number that is smaller than 25. Right? I can also add 8 because 8 and 16 give us 24. So which number here would give us 25? So 1 add to it would be 25. Right? So this would be 25. So 16 plus 8 plus 1 is 25. So since we use these three numbers, we are going to put 1 where they are. So that simply means we're going to put a 1 where the 16 at. We're going to put a 1 where the 1, and we're going to put a 1 here, and we're going to put a 0 and a 0, right? So we're not going to use up here because the number is 25. So we don't need to use 32, 64, 128. So we're just using these numbers. 1, 1, 0, 0, 1. You can put on the 2 for sure, so it's binary, base 2. Right? So this is what the computer see when you input 25 in the computer. So let us do another example. So we have 75 and we want to convert 75 into binary. Right? 75 into binary. The first thing that we're going to do is to look at this table here and look at the number that is less than 75. However, that number should be the largest number less than 75. So we know that we are going to use 64. Make any sense? So put a 1 and a 64. Right? So we can say, we can minus, so we have 75 minus 64. Right? So 5 minus 4 we have 1, 6 minus 7 minus 6 we have 1. Right? So we know that we need 11 more to add, and this 64 to make it to 75. So which number is less than 11? However, which number is the biggest number that is less than 11? That would be 8. So put a 1 where we have the 8. Right? So now we have 64 plus 8. So we know that 64 plus 8 is 72. So we need 3 more to add on these numbers. So the numbers are obvious. So we could use 2 and 1. You know, 1 plus 2 is 3. So we need only 3 to reach up to the 75. So where we have these blanks now, we're going to put 0. Make any sense? So we use 64, 8, 2, and 1. So I put as a 1 there. So where you see the numbers that we are using, we just put 1 there. So we're not using the 32, we're not using the 16, we are not using the 4, hence we put a 0. So the numbers that we are not using, we put 0 there, and the numbers that we are using, we put 1 there to add them up to get 75. So we have 64 plus 8 plus 2 plus 1 equal to 75. Therefore, 75 can be written in binary as 1, 0, 0, 1, 0, 1, 1. So when you type in 75 in the computer, this is what the computer read it as. 1, 0, 0, 1, 0, 1, 1. So this is how you convert a base 10 number to base 2. These are the numbers that your computer understand. Yeah, man. So when you put in those big figures in the computer only read the information as ones and zero. Yeah, man. Binary. Yeah, man. And you know, bi arrived from the word 2. So we know that binary is base 2 and decimal is base 10. So our answer is 1001011, and we have the 2. Yeah, man, because it's binary and we're talking about, and this is base 2. So we put the 2 to show that it's base 2, right? So this is how we solve a problem like this. This is the end of another informative and educational video. Yeah, man, so this is the end. So if you like the video, yeah, man, don't afraid to give me a thumbs up. Leave a comment in the comment section. Yeah, man, tell me what you want. Tell me. You can request on the topic. I may just do a video on it same time. Yeah, man, because maths on our channel, easy to learn. Yeah, man, thank you for tuning in. Thank you for watching. Learn with the Passleys. See you next time. See you later. Yeah, man, don't forget to subscribe. Yeah, man, it is free.